Dernière session de la journée qui, je pense, est une bonne manière de se chauffer pour l'after party d'après, parce qu'à mon avis, ça va être costaud. Ça va être costaud, mais Donia va nous expliquer tout cela en douceur. Vous faites du Kubernetes? J'imagine que oui, puisque vous êtes présent dans cette salle. Donc, vous connaissez les besoins quand on fait du Kubernetes, eh bien, de traçabilité, de monitoring, de supervision, télémétrie, etc. Mais également, pourquoi pas, identifier un comportement suspect. Eh bien, pour cela, une seule solution, eBPF, présentée par Donia, sous vos applaudissements.
Welcome to the Agrabah's kingdom. Tonight, you will discover a world of palaces and carpets, of lamps and jennies, and a kingdom we all travel through every day, the Linux kernel. We could have called this talk an intro to eBPF with Go, the foundation of modern Kubernetes networking. Kind of boring. Instead, tonight, we will discover a tale named Chaiehloudj and the eBPF lamp, a travel in the kernel. If you've ever tried to understand what truly happens under your applications when you run a Kubernetes cluster, why packets flow, why policies hold, why performance actually changes, you know that the kernel can feel like the Agrabah's market, the souk. It can be busy, beautiful, and a little dangerous to navigate. Dear troubadours and wanderers of DevFest, I'm Donia Chaiehloudj, and tonight I will be your storyteller about the eBPF lamp. So gather close. We will see how eBPF magic can elevate your developer life, your SRE life, your security engineer life for the love of open source. Let's meet our first persona, Chaiehloudj, in the marketplace. He's hungry, he's chased by guards, he has no visibility, no money, no defense, no time. That's kind of us sometimes in production. That's you, isn't it? When there is a packet that vanishes into the valleys, or a policy that fails silently. A CV that drops on a Friday in all the airports of the world, for example. Our tools at the surface aren't enough. Like Chaiehloudj, we're stuck outside the palace walls, guessing what happens inside. And top comments and logs and telemetry sometimes tell a story, but not the real story that is happening in the kernel. Which files are open, which syscalls are invoked, which packets are dropped or allowed. So if the souk can tell us the truth, we leave the streets and head beyond the city walls of the cave of wonders, the Linux kernel. Far beyond the city walls lies this cave of wonders. You might know it. The Linux kernel, inside there are treasures, like syscalls, sockets, packets, hooks, maps, all these names that we've heard about, but we just heard about them. We don't see them every day. They are kind of treasures. And the kernel, the cave, has some rules. If you touch it recklessly, you break not only your app, you break the full kingdom. And traditionally, if you wanted to change the kernel, you had to rebuild the full kernel. And it can take years before a patch can arrive in a distro. You can actually load modules, but it can be very risky for adventurers. What we need here is a way to observe and act deep inside the kernel safely without changing the kernel itself. And so our story begins. Chaiehloudj doesn't go to the cave by choice. He's pushed there, summoned by urgent needs, by a crisis, by a voice that says, if you want answers, you must go deeper. You have to analyze. You have to check all the logs, and you have to go much further in the cave. For you, for us, developers and SREs, that voice is an outage, a mystery packet, a policy that doesn't behave, some Jaffa-like pressure that forces us to find better tools. So Chaiehloudj is brave and curious, and he enters the cave. so might you. And within the cave, he finds 2 artifacts. The first one in this cave is the magic eBPF lamp. When polished, it releases an EB, a gentle genie who can run tiny programs inside the kernel safely. And eBPF lets us attach code to events. From the user space, when you have an app, you have events in your Linux kernel, and the eBPF program can attach to these events. What kind of events? It can be trace points, kprobs on the kernel, uprobs, traffic control, and XDP, express data path, but we will come on it later. eBPF is also verified and sandboxed. You can't crash your kernel. It's safe. If you write an eBPF program, it will be verified, so you're sure that your kernel is safe. And there are also maps that are shared data structures, which is interesting because you can actually share data between your user space and your Linux kernel. There are different use cases. The first one is you write from the kernel into these maps, and your app in your application can access it. So you can access all the mysterious things that you have in the Linux kernel. But you can think about also writing from the user space, from your app, a configuration from the user or from the Kubernetes cluster you might run into the eBPF map. And the eBPF program can actually retrieve all this configuration and use it inside. And the last one, which is interesting, is that you can run multiple eBPF programs, and they can actually communicate together and share data between them. These eBPF maps are like basic maps when you think about it. It can be array. We know about it as developer. But there are multiple eBPF maps that are very precise also, like per CPU, per packet, per type of packet. There are multiple types. But we'll not go into detail here about this topic. So the first artifact is the eBPF lamp. And Chaiehloudj found a second one, which is, do you know which one it is? The flying carpet. Of course. And today, our flying carpet is transformed into a gopher. Who is familiar with Go here? Oh, some hands. Interesting. So with Go, we are able, with libraries like Cilium eBPF, to compile all the C programs that you're going to write and run in eBPF, and load them into the kernel, attach them to hooks, read and write maps with clean, friendly APIs. So you can see it as a wrapper that will just help you to make it easier, so you don't have to bother too much with C code, and you can do it in Go code. And Go is a language of the cloud-native palace. Kubernetes, Docker, Prometheus, Cilium, you name it, familiar tools, familiar patterns that are all written in Go today. So together, the lamp, the eBPF lamp, and the carpet, the gopher one, mean we can explore the cave without getting lost. We have here an example of an app that will actually be written in Go, that you can load here an eBPF program, compile it directly, again, verified using Clang, and then you can use it in the eBPF maps, and finally, you can write and read with these friendly APIs from your Go code, and you don't have to do it in the eBPF program directly. Who likes C code here? Who doesn't like C code, sorry? Yeah, OK, makes sense. Do you remember what Chaiehloudj did with the lamp? 3 wishes with the EB Genie. So we're going to see which one is the first one. It's a bold one. He wants to become a prince. Make me a prince, he said to the genie. He wants visibility, power, access to the palace, and doesn't want to be hungry anymore. Without changing who he is, of course. And also because there is love in the story. So our first wish is the same. We want visibility. We ask EB, the eBGenie, to show us what the system does without changing the app that we're running or my laptop that is running. So what we're going to do is, first, we're going to write a C program to enable some tracing capability. We will write a C program. Yes, we have to start with that. So just for the sake of the example here, it's very simple. We are here on the line sec, tracepoint syscall sys open at, saying to the eBPF program that I want to attach my program to this specific syscall. This syscall is in the documentation of the Linux kernel, and you can find all of them if you are curious. Then the C function here, trace open at, is just saying that each time the program is invoked, we have the Genie whispering to us, file opening. In Go, on the other side, we wrote our C program. Then what we can do is to use friendly APIs I mentioned with the Cilium eBPF library. And in Go, what you can do is just generate a bunch of objects that are representing our eBPF programs in Go that we can use then. We can have the open file object here, which is programs, maps, variables that we will use in Go program, and then the actual bytecode, the eBPF bytecode that has been compiled, is available in the Go code. Now we have done that. We can write the Go program to load the eBPF program and do more. Here, we have this line load open file objects, which is saying that take my eBPF program and load it on my kernel. So attaching my program to the event, the sys enter open at. And here I'm saying link the trace point, trace open at, and finally some logs for the fun of it. And now it's done. So we have this Go program. So let's see what it looks like if we run it. Can you see well? Is it OK? Perfect. OK, so all the steps that I explained, they are already here. I generated all the C code. And I'm just going to run it so you can see what it looks like. So I'm using sudo, if you can see, because eBPF programs need a certain type of capabilities. Let me just rerun it so I have the proper logs. So it's very important to understand that eBPF has powers on your kernel. And not everybody can actually run eBPF programs. That's also why it's safe. So it is very important because it has a lot of power on the Linux kernel, but it's not dangerous on that point of view. So yeah, we're happy. We have our Genie that told us, without even rebooting, that we have some logs. And why do I have these logs, even though I'm not doing anything and talking to you? It's because my laptop is actually opening a bunch of files to run itself, because the Linux kernel is actually doing stuff. So that's why. So let's go back here. I have more examples. So this is the one that I just showed you, where I'm counting packet numbers. So this is more the observability part of eBPF. You can trace, and you can also observe. So basically here, my program is counting the number of packets that are incoming into my laptop. More precisely, onto my VM Ubuntu, because you can see that I have a Mac. And this other example is actually showing here. So you can see Go generate all the comments that I just mentioned before. And when I run it, I have a different output here. What I did is that I added a map where I stored the IP source and the number of packets that are incoming into my system. So you can see that you can add a bunch of information. This is a very basic example, but you can think about a lot of examples that are more developed, I would say. So the moral of this first wish is that we didn't recompile the application. We didn't stop the kingdom. We simply saw, like Aladdin dressed in fine silk, we gain legitimacy. We can observe from the inside with grace. But power invites challenge. In our tale, Jafar sees the prince's parade and tests him. In our system, threats probe our edges. A noisy neighbor, a suspicious IP, a storm of packets at the gate, again, some CVs in an airport. Visibility alone is not enough. The kingdom needs protection. Thrown into the depths, Aladdin uses his second wish. Save me when he is in the water, in the deep sea. We ask the same wish. Protect us at the earliest moment in the kernel if possible. And to do that, there is a specific eBPF feature, which is called XDP, Express Data Path. In fact, XDP is a point in the system that is at the earliest moment, the earliest network hook, we can decide a packet's fate before it travels far. It means that you can stop it or allow it even before it reaches the kernel itself. So you can think about all the benefit about performance, security, like your CPU is not overloaded with a bunch of IPs and packets coming that you don't want to. And on the code side, what is important here is that we're going to first hook on XDP, which is the syscall on the Linux kernel, and then check if the packet's destination is the one that I set up in my program. Is it blocked? If yes, I'm just sending a return XDP drop. If it's allowed, XDP pass. And again, it's very simple, but very powerful. So let's see also in real life what it looks like. And I'm going to run my program again here. And I'm attaching my program to a specific network interface, which is loop, which is itself, for the sake of this example. And on the other side, I'm going to ping my local host. And you can see that the packets are dropped. Again, I didn't reload my laptop or my VM to be able to do that. I can do that dynamically. And now I'm going to stop the ping. I'm going to stop the program, sorry. So I'm not dropping the packet. And you can see that the ping is actually doing his job now. So the moral of this example in this wish is that when the sea turns rough, eBPF can pull you out of the surface, not with a blunt force, but with an elegant control at the kernel's edge. And so the prince reaches the palace, our Kubernetes cluster. Our kernel, why does eBPF matter here? Because a cluster is a city of pods. It's dynamic, ephemeral, noisy. We know that our pods are rebooting all the time with new IP addresses. And what is interesting with eBPF is that we have one kernel per node and many pods. So eBPF gives us a single and privileged vantage point to implement networking, observability, and security for all tenants, all in one host. So that's very interesting that we have all these use cases. We can encode policies, track flows, measure latency, export more metrics that are available only in the kernel, all without sidecars, without kernel patches, and with predictable performance. Let's say that's another topic and maybe another talk. But with Go as our carpet, as you can see here, we can ship agents, operators that manage eBPF programs, creating maps, updating policies, reacting to events, integrating with the control plane on your Kubernetes cluster. And the palace prospers with its guards and guides are lightweight and wise. In fact, Aladdin's final wish is the most generous one. He says, I wish for the genie's freedom. He understands that magic locked in a lamp serves only one person. Freed, it serves the world. For us, this is where the EB leaves a single node and spread across the realm. And we can build many tools that are actually open source, like Cilium. And Cilium uses eBPF for Kubernetes networking, efficient data path, identity-based policies, transparent encryption, and much more. A living map of flows in the cluster using eBPF. And maybe you know or you don't know, but you're maybe running Cilium without knowing, because many of the main cloud providers are using Cilium as default on the CNI, on the networking layer, instead of the default one. Or maybe you can tune your provider to use it. So you're maybe running already eBPF without knowing it, and you are using this magic. There is also another tool, which is Tetragon, that uses eBPF for runtime security, so preventing, again, at the earliest moment, and securing clusters. And in both go orchestrate the Genies work, loading programs, updating map, reconciliating state from Kubernetes between pods, turning raw magic into a reliable infrastructure. When the Genie is free, standardized, open source, integrated, everyone benefits. Platform teams, developers, security, and ultimately users. And our story began in the dark, a cave of wonders where power was kind of risky. And we found a lamp, eBPF lamp, that lets us write tiny, safe programs in the kernel. We found a carpet, a Gopher carpet, that makes those programs practical, observable, and maintainable. And with 3 wishes, we learned that we can do tracing, reveals the truth without breaking the spell. We can have security with XDP, which protects the kingdom at the gates, and observability and networking scale to the Kubernetes palace, where projects like Cilium and Tetragon and many more serve the realm. And the lesson of Aladdin is not about power, it's about wisdom. Use the Genie well, free it into the ecosystem, build tools that helps everyone. Thank you for listening to this tale. May your cluster be calm, your packet swift, and your Genies kind. I'm Donia Chaiehloudj, and if you want to explore more, here are some resources and credits. And there is also a hackathon. There is also a hackathon actually on eBPF that is running, if you are interested, if you want to explore. I would be more than happy to talk with you. And feedback is a gift, a speaker said this morning. So thank you.